My objective here is to try to create this drawing, this piece of art, not by using pen and paper or any digital tools, but instead by using maths and coding. So in other words, I want to create this using algorithms in an algorithmic way. So that's the objective here. So for reference, this is from this website called Alex Codes Art. And the thing is, it already has a lot of code. It has already been done. But for me, I'm not going to refer to any of this code or anything. I'm just going to go from first principles. Just use my knowledge that I have so far and try to recreate it as much as possible. And I know the whole image also includes the waves and all, but for this one, I'm going to ignore this part. Just try to draw this one only. Just the actually it's a circle. It's a sun. That's what they're trying to make here. Okay, so let's do this. And for this, I'm going to use the p5.js web editor. So this is what we're going to use. Okay, so let's start. To begin with, we start with a canvas with a size of 400 by 400. And if you run this, so you can see this canvas. So what we're going to do here is start by creating a circle at the beginning of, at the center of the canvas. Now, I should also mention the coordinate system here, the coordinate system. So this here, the top left corner, that's the origin point. So that's the 0, 0. And if you move right, that's the positive x-axis. And if you go down, that's the positive y-axis. Now it's a bit different from what you're usually used to. Normally what happens is that when you move up, that's the positive x-axis. And when you go down, that's the negative y-axis. But here, it's opposite. If you go down, that's the positive y-axis. But the x-axis is the same. So you have to keep that in mind. So now if you want to create a circle at the center, what you need is that the center of the circle should be at the center. That means the coordinate should be 200 by 200. Okay, so we'll use the circle function. P5.js's built-in circle function. So here we will put three parameters. The first parameter will be the x-coordinate of the center of the circle. The second parameter will be the y-coordinate of the center of the circle. And the third parameter will be the diameter of the circle. Okay, so these are the x and y coordinates. And then for the radius, for the diameter, let's have a diameter of 100, which means the radius is going to be 50. Okay. So that's fine. So if you look at the reference image, we have created this circle. Of course, we can definitely work on the colors and all the aesthetics of it. But for right now, we'll focus on the overall structure. After that, you can focus on the colors and so on. So the next thing we're going to try to do is create those rays. Okay. So my approach would be a bit different from what is being done here. And I'll also go about this thing step by step. Okay. So first of all, what I'm going to do is to create a circle. Okay. And also, instead of triangle, I'll start with a circle as a prototype. And once we are done with the algorithm for how to generate those rays as circles within this thing, then I'll switch from circles to triangles. So that's going to be my strategy here. Okay. So what's the simplest method to do this? That is going to be to create a circle based on the coordinates. So let me go back to the notebook here. Switch to the notebook here. Okay. What you're going to do here is this is the circle that you have here. Okay. And the coordinate is 200. This is the center. And within this line, I want to create a circle somewhere around here. Okay. So what should be my strategy here? What should be my approach? Also for reference, these are the axes. This is the positive x-axis. This is the positive y-axis. Now, now we already know that this length here, this is 200. Similarly, this is 200. Okay. So for this point, the y-axis, we want to figure out the x and y-axis, x and y coordinates. The y coordinate is going to remain the same because this is the same height. So y is going to remain as 200. And what about the x-axis? For that, if you want to create a circle that is at a distance, certain distance from here, we also have to take into consideration about the diameter of this circle, of the smaller circle. Okay. So suppose let me create the circle with a diameter of 20. That means the radius is going to be is going to be 10. And we already know that the diameter of this circle is 100. That means, let me change the color. That means this part is 50, which also means that means this part is also 50. That means on the x-axis, this point is 250. Okay. And now if I want this point, this circle to be of diameter 20, that means its radius has to be 10. And I also want a bit of gap here. Let's also include the gap to be of 10. So a gap of 10, this, and again another gap of 10 because that's the radius. Okay, so this adds up to 250 plus 10 plus 10, which equals to 270. So the x coordinate of this point should be 270. So essentially what you have to do is to create the circle function with x-axis of 270, y-axis, y-axis is going to be the same of 200 and the diameter will be 20. So that's what we're going to do now. Let me switch back to the p5.js. Okay, so let's create this new circle, 270 comma 200 comma 20. See, we have created this circle here. So similarly, we can create another circle here, here, and here. with very similar logic. Okay, so essentially what we have done here is that we have increased the uh, value of the x coordinate by 70. So similarly, if we decrease the value of the x coordinate by 70, we are going to create a circle here and keeping the y-axis the same. So for example, so let me just demonstrate it to you. So okay, so from 200, instead of adding 70, we are subtracting 70, which gives us 130. And the y-axis is going to be the same. And the diameter of the new circle is going to be the same as the other one. So if I run this code, we should get a circle here. And as expected, this is what happens. Now, similarly, what's going to be the logic to get a circle here and here? So switching back to the uh, notebook. Okay. Now, to create a circle here, what's going to happen is that the x coordinate is going to be the same. The x-axis is still the x and y-axis. Okay, let me remove this thing. Okay, if you want to create a circle here, the x-axis is going to be the same 200. 200. What about the y? For y, we're going to shift up 50 plus 10 plus 10. So it's going to be 270. So the y-axis, y coordinate was going to be 270. So conceptually, it's quite similar. It's exactly similar to this circle, except instead of changing the x-axis, we are changing the y-axis here and keeping the x-axis constant. So let's go back to the P5J sketch and it'll be clear. So the x coordinate is going to be the same. We're going to increase the y coordinate by 20 by 70 and run it. We get this one. And similarly, the next time, again keeping the x-axis same, and instead of adding 70 to 200, if we subtract 70 from 200, we're going to get uh, a circle at the other end. Okay. So far so good. This is quite simple. But using this technique, it gets difficult to figure out the coordinates of this point. Suppose if I want to create another circle in between these 2 points, another circle between these two circles here, here, here. How do I figure out the coordinates for these points? So using this approach is going to be difficult. So for this, there is a much more efficient way to go about this, and that is by using trigonometry. So how to do that? So I'll go back to the sketch and then go to the theory of it. So there we have this circle. Okay. And let's consider this origin, the center of the circle to be 0, 0. Okay. And we know that the radius is 50, so this point is going to be 50 0. Similarly, this point is going to be 0, comma 50. But if we take any arbitrary point within this range, let's say this point P, which is at an angle theta from the x-axis, and you want to figure out the coordinate of this point, how do we figure it out? So we can do this by using the tools of trigonometry. So what we're going to do is we're going to draw a perpendicular from the point P to the base. Okay, now this becomes a right angle triangle where this red line, this is the perpendicular, this one is the base, and this is the hypotenuse. Also, keep in mind that we know the value of the hypotenuse. This is 50 because these three lines are the same thing. These are all the radius. So all three of them are the radius, and we already know the value of the radius, which is 50. So given this information, if you want to figure out the uh, values of the x and y coordinate, so what is the x coordinate? It's nothing but the base. This is the x coordinate, x comma 0. And what's the y coordinate? It's nothing but the height. This is 0 comma y. So if you can find the value of the base and the height of this right angle triangle, you can figure out the x and the y coordinates. So, so for this, we can use the trigonometric ratios. Okay, for the x-axis, we can use the cos theta ratio. So we do know what cos theta is. Cos theta is base by hypotenuse. So rearranging this equation, base is equal to hypotenuse multiplied by cos theta. And base is nothing but the x-axis. Hypotenuse is nothing but the radius. And cos theta will keep it as it is. So we have found a formula to find the x coordinate in terms of the radius of the circle and the angle. Similarly, for the y-axis, we can use the trigonometric ratio of sine theta. So sine theta equals perpendicular by hypotenuse. So rearranging the equation, perpendicular is equals to hypotenuse times sine theta. Perpendicular is nothing but the y coordinate, hypotenuse is the radius, and sine theta we'll keep it as it is. So we found a formula in terms of the radius and the angle to to calculate the coordinates of any points within this axis, within the circle. So we're going to use these two formulas to find the coordinates and draw the circles, those coordinates. And before moving, let me also clarify the coordinate system here. So previously I mentioned that usually what happens is this is normally the way we use the coordinate system. But the coordinate system of P5Js is the mirror reflection within the x-axis. Okay, suppose this is the mirror and this is just a reflection of this one. So I'm doing this so that you have a better idea of what I'm trying to do, and it will also help you make sense. Okay, so what we do here is that we are going to draw points. So this is at 8 different points here. This is going to be at this point is at angle 0 degrees. This point is going to be at theta equals 45 degrees. So one circle here, another circle here, another here at theta equal to 90 degrees. Another, this is going to be 180. This is going to be 270. So 90, 45, 135. Another circle here. 180 plus 45 is 225. And 270 plus 45 is 350. So these are the 8 points where we are going to do this. Also, the angles are calculated counterclockwise. Okay. Now, how is this going to look? So this is how it looks on a normal coordinate system. How is this going to look in P5GSS coordinate system? So we have to use a bit of our imagination and our spatial reasoning capabilities to flip this image. Okay, so let's try to look at this. How is this image going to look like if I turn it around? Okay, this arrow will look something like this. And we have these 8 points. The 0 will be here. The 45 will be flipped and will be here. And the 90 will be here. And I think so from here onwards, I think so you can figure out the pattern. 90, 135, 180, 225, 270, and 350. But this is how it will look like here. And to test our theory, let's now go back to the P5J sketch and we'll code this one and see if this works. Okay, again, also remember this thing, the formula for the x-axis and the y-axis. And one thing also, I also have to mention that will come up in the code is this thing. Previously, I mentioned that this is 0, 0, but we know that our coordinate of the bigger circle is not 0, 0. It's 200, 200. So we'll also have to factor in this thing and shift the x and y axis accordingly. So the x and y points is not simply going to be r cos theta and r sin theta. That's not going to be it. We'll also have to add this thing. We have to factor in this. We have to shift it that much. Okay, so it's going to be 200 plus r cos theta and 200 plus r sin theta. Uh, it's not very legible here, but once it go back into the code, it will make more sense. So let's get back into the code. Okay, so let's remove this one. Okay, remove this thing. Now let us use our new trigonometry formula to create a circle. So instead of r, the radius is 50 into cos 0, 50 into sine 0, and a diameter of 20. And notice that I haven't added the 200 here. So just to demonstrate this. So ideally, what we want is that this code should generate a circle at this spot, but it won't. It will create a circle at around somewhere here because so far we have not factored in this shifting. So it will consider this to be the origin point and it will create a circle at a radius of, at a distance of 50, um, yeah, at a distance of 50 from this. So the circle will appear somewhere here. Well, it hasn't. It should have. Yeah. A error in the syntax. Think. Yeah, you can see. It appears here, but we do not want it here. We want it to be here. So we have to add 200 to make the shift. So we're going to add 200 here and 200 here. And now the circle should appear here as per our image. See, you can notice this thing. Now let me, oh, okay. Okay, now as per our diagram that I previously showed, the 45 degree should be here. So if I now change the angles to 45 degree, the next circle should be created somewhere here. Also, before continuing, we have to increase the length here because at 50, the coordinates of the circles are just at the circumference, but we wanted it to be a bit further forward. So let's continue and make it 70. Instead of 50, we're going to do it 70. And here we go. Okay. So this time I'm going to simply copy paste the same code and change the angles from 0 degrees to 45 degrees. So what's going to happen right now here is that this, the next circle will be created here at this part. Yes, I think so, yeah. It does look a bit off because I think we are, okay, let me just try for 90 degrees and let's see if it's off too much. Yes. So I think we can fix this by making sure that these angles are in degrees and not in some other thing. And for that, we can use this function. And let me see if it works. Yeah, you can see the changes now. So again, if I comment this out and try to run this program, you can see the placements are not very proper because the angles are not in degrees here. So we have to make sure that the angles are in degrees. And with that, the positioning is proper as you want it. So again, for the fourth one, for angle 135 degrees, the next circle will be somewhere here. Okay, so I think so that you've got an idea of the pattern, how it's going to turn out to be. So I'm going to probably fast forward this thing for the rest of the circles. Okay, so as you can see that using this formula, we have created this circle, this patterns of circles around the main circle. So which is that these are supposed to resemble the rays, and the bigger sun is supposed to, the bigger circle is supposed to resemble the sun. And if you compare it with our target image, so it's beginning to take the form that we are trying to achieve. Even though it's not quite exactly the same yet, but at least it's starting to take the form. Okay. And so what's next? So the two things that you can do here is that the first thing is, more importantly, the first thing is the shape. Right now it's just simple circles. So, but in the target image, what we have here is that these are triangles. So what you have to try to do is try to create the triangles instead of circles. And the problem with I don't say the problem, the challenge with triangles is that I will also have to figure out the angles of the triangles. I know, but that's not the difficult part because we have already figured out the triangles. Sorry, we have already figured out the angles here. So we have to create the triangles based on that. So that's the next thing we're going to do, to replace the circles, the smaller circles, with the triangles. And the other thing that we can do is more from an aesthetic part, is to change the colors. Okay, it's right now it's just plain white. So you can switch it to orange. So these are the two things that I'll be tackling in the next session. Okay, I think so that's it for this session. We'll continue in the next one.